Hey, why don't we go ahead and get started? My name is Mark McCurry. I want to welcome you to session VTL31, Coming Together in the Cloud. I'm a director in the Platform Strategy Group at Microsoft. I'm joined today by two guests. I have Rick Boykin, the technical director for Mondo Robot, and also have Jeff Norris from NASA JPL that I'll be interested in later on in the talk. Now, the session for today's talk is Coming Together in the Cloud, and what we're going to talk about is a number of different things related to this project that we built. Before I get into that, was anyone at TechEd last year where we introduced something called RoboChamps? We did a Mars rover challenge with NASA. Okay? So we introduced that challenge. We're driving our robotics toolkit. We're very invested in STEM education, STEM being STEM, science, technology, engineering, and math, as is NASA. And we said we had a really great experience. They're a really great partner to work with. Everyone's really passionate about what they're doing, and if there's a way to combine technology and what they're doing and for us to work together, we said, let's find some other ways that we can do that. So we're going to talk about today as one of those projects. And before I get too far, I want to talk about when we talk about NASA today. NASA's a large organization just like Microsoft. We're talking about the Jet Propulsion Labs in Pasadena. And JPL is known primarily for the robotics missions to Mars, like these guys right here. These folks are actually on display if you happen to be in the conference today. I know we're going over the web as well as in-house here in LA. Please be sure to check them out in the big room. We've got replicas of all these in the back of the room, and NASA's been kind enough to send folks to staff the area. So any questions you might have, they can answer them there. So when we talked about what we could do, we said, all right, let's see what we can do around STEM education, and also see if maybe there's some real-world business problems we can solve in the process. So one of the things that came up is that between the orbiters going around the planet and the rovers, there's a fair amount of imagery that's being taken. Hundreds of thousands of images that are there. More than you can imagine that the staff on hand could process. So it's important to have those pictures looked at because there are things that are happening there that could be very important, whether it's from understanding dust storms and what's happening on the planet, but very basic things like building a map of Mars using these instruments. Right now, there's an instrument called MOLA, and that's the only map that we have available that covers the planet. So we said, what if we could do this? What if we can involve people in citizen science? Because citizen science is a way for people to get engaged, everyday citizens to be engaged with science. And it's a core, when you're looking at that and you're thinking about STEM, they go hand in hand. Is there a way for us to drive STEM education and maybe at the same time educate people while they're also allowing us to help us using citizen science? And that's what we decided to put together, and that's what this talk is about. So what we built is this thing. It's called the Martian Map Room. It's one of many experiences that launched yesterday, as well as a codenamed Dallas data API available from NASA. And there's also something called the Pathfinder Innovation Challenge. So what today's talk is about, and I want to make sure I set the stage for everyone, is to talk about the genesis of this project. And this project included a number of different organizations and involved NASA, of course, Arizona State University, who worked with NASA, an organization called Galaxy Zoo based out of Oxford, Microsoft, and Mondo Robot, a great partner of ours to help put together this particular experience. So today's session is to talk about how this application came together, some of the design decisions of what came together in the process. We'll talk a little bit about Galaxy Zoo and how they moved from Amazon's cloud to ours and why they did that and some of the things we looked at there. Rick is going to go into the Silverlight client, how we use WCF and some of the REST toolkit pieces there. I'll talk about ASP.NET MVC in the first part of that session as well. And then we'll also have Jeff talk about the Pathfinder Innovation Challenge. And that's a real opportunity for you guys to actually do some programming against the APIs, to do similar things to what we did here, but you guys can win all sorts of great prizes. That we did it for work, and you guys could do it for fun and come away with some really neat prizes, either as individuals or with teams. So a lot of these times we show you a lot of code. We don't show you actually what we built. We're going to start off with a quick video that shows you what was built, and then we're going to go into the different pieces of it. You know what? You don't need to hear that. 1 second. Slight technical difficulties. There we go.
Map Room and joining the global effort to produce the best Mars map ever. By counting craters, you can also help find out the relative ages of small areas on Mars, such as dried out stream channels, some of which may be important to understanding when and whether Mars might have had a habitat for life. Here's how you can map Mars and count craters. Let's begin with mapping Mars. You'll have some easy tools to line up each image of Mars precisely. First, you'll be given a set of 3 images to line up with a background image. You'll have a simple tool to nudge each of the 3 images into place using arrow keys. Finally, when you're sure the 3 images are correctly lined up, hit the Done button and earn 100 reputation points for your contribution to Mars exploration. Here's how it works. The large background image you see here was created by an instrument called MOLA, on board NASA's Mars Global Surveyor Orbiter. MOLA measured elevation, or the highs and lows, of the whole globe of Mars. This image is one of many that together make up the only fully aligned map we currently have of Mars. With your help, we're going to add to that baseline map using increasingly higher resolution images from cameras on Mars orbiters. When all are combined with MOLA, we'll be able to create better 3D fly-throughs, zoom-ins to the surface, and more. It all begins with you. On top of the MOLA background image is a set of 3 Themis images. You can see them at the right of your screen in a stack and also highlighted on top of the background MOLA map. Using the MOLA map as a guide, nudge the pictures into place one by one. You will use the arrow keys to position each image carefully. Look for things such as crater edges that can help you align.
So you get an idea of the interface that we've built here. So this is one of the experiences that we've done. There's another one that's going to allow you to count craters, which is effectively what you're seeing is you're seeing casual games. Once you actually get into building these things out,
you can also choose to count craters instead.
And what happens is
Let's try a counting craters task now.
Let's take a quick look at this.
A large background image will appear on your screen. This time, it's a single Themis image. Here's how to count craters. Click on a crater in the image on your screen. You'll see a circle appear. You can resize the circle by clicking on the outer band of the circle and dragging it to match the size and outline of the crater beneath. If you want to move the circle, you can click on the center of the circle and drag it into place. Now, when counting craters, we're not going to ask you to count the really small ones. When a circle is displayed on the screen, it will be displayed at its minimum size. If you see a crater smaller than that...
Okay, so you get a general idea of what we're doing there. Now, at a high level, what we're talking about is there's data that NASA has that they want to make available to the public, right? From their perspective, as citizens, we paid for the data, and they're incented and very eager to make sure that we can connect with that. So there's exposing that data. There's also the piece of how can we get people engaged in citizen science and provide a very interesting user experience to make science more engaging for them, driving both of our goal of driving STEM education. The other thing to think about is that we also want to be able to help solve some of their business problems, right? How can we, and really their business problems are our business problems, right? Because knowing more about Mars is going to benefit all of us. So how can we engage everyday people? Because most people do want to contribute, and help them contribute in such a way that it's very straightforward, it's a casual game, it's fun, they're learning, and they're also helping solve some of the larger goals. We also need to be able to scale, and I can tell you firsthand, because we launched it yesterday, that the need to scale is actually very much there. And we have scaled multiple times today using Azure. So we're now at 24 servers that we've scaled over the course of a couple different allotments during the course of the day, and it couldn't have been easier. We basically go in and set the configuration file and go from 5 web servers and 5 web service servers, and just go in and say 10 and 10, and we bump those up. So it's actually pretty straightforward. But enough about the high level. Let's talk about the sort of the background and what it is that we did and how this all came together. So we talk about citizen science. There's an organization out of Oxford called Galaxy Zoo. They are one of the trailblazers in the field as well as far as citizen science is concerned. They have a website where you get an interface, this very one, where you get some very simple questions. You go and click a classification of this galaxy, and that helps them drive real work. And some people say, well, how much does that actually help? They've actually published 10 papers based on the contributions of the community, and that's only for lack of time. They've got a nice backlog of papers that they could publish. In addition to that, they have 250,000 people that are regularly engaged in their community, contributing back to the project. So as fate would have it, at Microsoft Research Division, we have what's called a Jim Gray grant. A Jim Gray grant was given to Galaxy Zoo early on. They came to, fortuitously, they came to speak at Microsoft to talk to the research team, and Dan Fay and the research organization said, hey, Mark, you want to come by and see what these guys have to say? And it was very interesting, and we realized they have something that's in place. They have a wide following. They have a lot of lessons learned. It doesn't make sense for us to go and recreate the wheel. And they also had 30 projects in queue. So not only was it interesting for classifying galaxies, but they had projects, everything from ornithology issues to translating ancient texts. So there's a huge group of individuals that wanted to do this sort of crowdsourcing, this citizen science, across a number of different areas. So what we did is we pulled Arfon and Chris aside. It's Arfon Smith and Chris Lintoff, and said, all right, well, tell us a little bit about the background of Galaxy Zoo and how did they come together. So initially it was a website. They got on the BBC and The Economist. They very quickly realized they needed to scale, and they built a platform. So they have a REST interface implemented in Rails that goes out to backend storage that happens to be sitting in MySQL. It's running on Ubuntu, and it happens to be sitting in Amazon services. We said, all right, well, that's interesting. It's good to know. And from their background, they were fairly technology agnostic. They just had a problem that they needed to solve. Amazon was the commercial vendor that was available at the time. They went with it, and it was serving them just fine. The challenge is that they were doing a lot of the IT work. There's a fundamental difference in approach between uploading an application to managing a server and all the infrastructure that's related to it. So it was taking some time for them for their one site, but as that was expanding out to 30 different sites, it became a bit more of a challenge, and based on the trajectory, there's going to be more than 30 sites. So we talked to them about the differences. They really liked them. And they said, well, could you help us move over to your platform? And they said, yeah, absolutely. Let's do that. And what we did is we moved them over to ASP.NET MVC for their front end, using SQL Server Azure services for the data store, and it's all hosted inside of Windows Azure. Because for them, they have the same spikes that we saw today with NASA, right? There's initial interest, there's different publications that come out, media interviews, and there's huge spikes. And you don't want to have to pay for servers for max load all the time. And because these guys are scientists first, developers second, and IT folks last, we're letting them focus more time on the science. So if they're spending 20% of their time doing IT work, that's 20% time too much. Now, I recognize I'm from Microsoft. What we have done is, Arfon couldn't make it here today. We did pre-record a video with him. So if you go to channel9.msdn.com, you can hear him and Chris talk about Galaxy Zoo in his own words as well. So don't just take my word for it. So we broke it out. We recognized there were a couple of different pieces to this. There's a data layer that we were going to build in Windows Azure, SQL Azure, and WCF, Windows Communication Foundation. There's an ASP.NET layer. There's a Galaxy Zoo API layer, which is in ASP.NET, MVC, SQL Azure, Windows Azure, and then we have a Silverlight front end. As we were building this out, Mo over in the Dallas team said, hey, I understand you're working with NASA. We'd really like to expose that as a data set. And we said, all right, well, that's good. What's it going to take? It was actually only an incremental level of investment to make that available to the rest of the world. We said, we're definitely going to do that. So what are some of the challenges or things we need to look at as we went through the process? One is we had a number of different organizations working together, right? We had ASU and NASA and Microsoft and all the rest, and coordinate all that. We had some technology issues that we all needed to address because we all came from different places as far as what was acceptable. So NASA is a government agency. So as much as we'd like them to use Windows Live ID, it's not an approved identity provider for them. And traditionally, Galaxy Zoo had been the host of the IDs for these folks. And again, that wasn't going to work. So what we decided was we would do it with a hybrid approach. Here's what you saw yesterday and what's going to be coming out in a v1.1 soon. We said, all right, we're going to take ASP.NET membership, so we have traditional username and password. We're also going to augment that with OpenID. So we've added OpenID support to ASP.NET membership. And the reason for that is if you're building something like this, think about Chris and Arfon. They have an audience of 250,000 people that like to engage in citizen science. NASA has a very large audience as well, and we're going to see what the size of that is. We shouldn't introduce friction from people going from one site to the other. And for us, we thought OpenID was a great first step for people to be able to take their existing credentials from that site and come over here, and potentially vice versa. Now, the other thing we wanted to do is it wasn't just about the ability to log in, but we want to make this fun. These are games, right? And if you're going to play a game, you want to have points. You should do it because it's good for mankind, but a lot of people want points. So we said, all right, what we're going to do is we're going to hook it up to a reputation system. So you're going to be able to earn points. So every time you count a crater, every time you nudge pictures into place. There's another app, part of the site, which is a town hall application, which allows you to ask questions and you can vote on questions. You're going to get points there. And as you go through it, you're going to be able to accrue points and get these badges across different categories. So whether it's for curiosity points or discovery points or citizenship points, you're going to be able to earn these badges. So we built this all on top of ASP.NET membership. Now, for the interface itself, as I mentioned, Galaxy Zoo has a Rails-based API. It's REST-based, and then people are building different types of front ends on top of that. Some of them are Silverlight, like we've got. There are others that are Flash, others that are in Rails as well. And because they have a backlog of existing customers and new customers that are in the pipeline, they said, all right, we want to do this, but we need to have 100% backwards compatibility because these people have built on our platform. So it was actually pretty straightforward to do, and I'd like to tell you it was really difficult and I had to go deep. But a lot of stuff we had out of the box worked with just some minor tweaks. So what we did is we used ASP.NET MVC. We used the REST toolkit for that. It's now part of ASP.NET. We used ASP.NET 2. I'm sorry, ASP.NET MVC 2. And we had an early build of the new version of the REST toolkit. It's now part of ASP.NET MVC Futures. But it made it very, very easy for us to go and just add a couple of attributes. And this is now exposed as a REST API. And we just decorated our controllers. The one thing where we did have something that didn't work out of the box was in serialization. So for Galaxy Zoo on Rails, they serialize everything out as plural. So here you can see an asset, and it's held inside of an assets collection. If you go ahead and serialize out of the box on Rails, you get that. For us, you get array of and then the entity. Pretty easy to fix. Make a new class, asset list, derive it from list of assets, and you can go ahead and name the collection data contract, put in the name for the container as well as for the item. So that was pretty straightforward to do. SQL, again, it wasn't particularly difficult to move it over. Got the schema from them. We put it into SQL Management Studio. We recognized really quickly there were a couple of things we needed to do master places on. Went in very well. We did make a couple of enhancements. I'm not going to talk about them here, but I can answer in Q&A or afterwards, where we looked at things that if you're working in a distributed world, you'd want to make things so you could very freely switch identity or places where the assets live. And when we talk about data, I think it's really important to talk about one of the key aspects of the project, which I think is different, and I like a lot, is that NASA is exposing data via an API. People are adding value on top of that API, and Jeff will talk about that in the challenge and what they're doing there. And that value that's added by the community goes back into what NASA has, then can be exposed back out. And it's this virtuous cycle where the community, engaging in citizen science, building these types of applications, are adding value that's contributing back to the organization. And you're going to see, I think, more and more of that with crowdsourcing as it moves forward. And with that, I'm going to turn it over to Rick Boykin. Rick is from Mondo Robot. I'll turn it over to you, Rick.
Oh, great. Thanks, Mark.
And you're in this guy here.
All right. Well, I want to apologize up front. I don't have any slides. I was basically working to the last moment to get the website up and running for the application.
Rick, this is the PDC. They don't want to see slides. They want to see code.
Great. Well, so I do have code, but let me give you a little background. First off, I'm from an agency called Mondo Robot. We're a digital agency specializing in interactive and highly visual stuff. And Mark actually found us when working on RoboChamps because we had the name robot in our name. So it actually turned out to be a really good thing, but kind of interesting how he found us. Mark contacted us to help out with the application, and the really cool thing about it, and working with Mark in general, is that it touched on a lot of different technologies, and not just different technologies, but new state-of-the-art cutting-edge technologies, things like Azure and Silverlight 3 and WCF and REST services built on top of WCF and stuff like that. So. Not only that, but we got to work with a bunch of really cool agencies like NASA and Microsoft and Oxford University. So immediately we picked it up and said, yeah, this looks like a really cool app, something we want to work on. So we started taking a look at it, and we looked at the Dallas code. The Dallas code is the code that is it's a service that's used to collect data from Dallas, and it's the actual images of Mars and the metadata that's associated with them. So they have a huge database of images from different instruments that either fly past Mars or orbit Mars, and they organize that into a database, and they each of those images has metadata associated with it that kind of gives you the latitude and longitude of where that data is located on the planet. Then they have an older data set that's called the MOLA data set, and it's a little lower in resolution. So the whole purpose of the Mars mapping app is to take this higher resolution data and try and fit it with this lower resolution data so they can correlate the two and figure out where everything goes. Another part of it was the Galaxy Zoo thing, which Mark had mentioned. From our perspective, what we really needed was a Microsoft client that could talk to this REST service. And fortunately, WCF has some really nice tools for doing that. So with less than, I think it was 700 lines of code, we were able to write a client to connect with this fairly extensive REST service and be able to talk to it on pretty much every level. So I think there was like 650 lines of actual C# code and probably about 20 lines of config file that goes in your web.config. So we found that really exciting. It saved us a ton of time. I had been involved in writing clients for REST services prior, and it turned out to be really huge libraries where you're using the web client to communicate back and forth and all the error checking. But with the WCF stuff, it was just right out of the box. Actually, I can
Just click OK on that, you'll be fine.
show you some of this code. A lot of OKs. Oh boy, tiny. Please bear with me while I locate this stuff. Everybody's open here. We just transferred the code to this computer right as we were opening up the talk. Galaxy Zoo. So really the hard part of creating the WCF REST client was creating the interface and annotating it with the WCF, or the REST attributes. So here in the first section of the code, you get a little bit of a taste of what we were doing. First, we created a service contract. And to be a little more compatible with non-Microsoft REST XML, we decided to use the XML serializer format. And the reason for that is that we couldn't guarantee that the XML elements were going to be ordered in a specific way. Now, the data contract serializer expects elements to either be ordered alphabetical or in a specific order. And with the XML serializer, it's a little more free format. It allows you to accurately read in XML that's formatted not so tight to the standards for XML elements. Then the first interface element you see there is just an adorned interface element that implements the REST service GET for this particular method. And this particular method is GetUser based on the user ID. And as you can see, it is a web GET. It has a URI template for the REST service, bare style, and just straight up XML. And basically, this whole file just looks like that. And then the actual implementation of this file looks like, here's the same user at the very top. And basically, the get user, and it just uses the WCF channel to go ahead and get it, and all the work is done for you. No web client, no error checking. It's all just kind of out of the box. We found that to be really awesome. And based on past experience, I will definitely be using that again for any other REST communications that I need to do in the future. So that was our experience with the Galaxy Zoo, and that went a lot quicker than we expected. So then we started looking at the Silverlight application, and the Silverlight application is the interactive application that allows you to select the craters and do the actual image mapping. Typically with Silverlight applications, we create at least Silverlight applications that are going to consume data, is we create some sort of service to talk to a server to be able to bring that data in. And that was certainly the case for this one. So we created a WCF service that the Silverlight app could talk through, and then hosted the Galaxy Zoo and Dallas services on the back end, and then used some just standard WCF data contracts for transferring data back and forth. And the reason why we hosted the Dallas and Galaxy Zoo services on the back end was because we had to do a little bit of processing. With the Galaxy Zoo app, you're basically getting back single tiles of images, and we wanted to be able to stitch those together and bring those to the app without having to do a ton of service calls. One of the quirks, and rightly so, with Silverlight and talking to an app is everything's done asynchronously, which can lead to a little bit of weird UI or a little bit of odd behavior. Certainly, it's there for a reason, and it's great that it is there. But in order to get around some of that little bit of oddness, we decided to do some of the processing on the back end. And then we were able to do single calls to the back end and bring back data in bigger chunks. So we have this Silverlight app, the WCF layer, talking to the back end, bringing back images and pieces that we needed to piece together for building the background images and then the individual images that go on top of that for the mapping application. And then, of course, once the user's done, we gather up, aggregate all the data that the user's input, send it back through the WCF service layer, and ship it off to Galaxy Zoo, and Galaxy Zoo ensures that that is stored in the database properly and associates a user with it and all the data and such. So we have the Silverlight application, the back end, the Dallas, the Galaxy Zoo. Another piece of it was a piece of software called Ingot. Ingot is a model robot library that we've written for internal use for ourselves. And basically it's what we call a nugget library. A nugget's basically a glorified blog entry, so it has a user associated, has text associated with it, perhaps rating, what else? Rating and user information, yeah. And it has a fairly extensive layer for doing the rating stuff. So we used a lot of that rating stuff for doing the question and answering portion of the app. I'm not that familiar with it because it was written by some of the other folks at Model Robots, so I'm not going to go into it in too much detail. As another layer, we had the Crater City specific stuff. So this application was codenamed Crater City prior to the release, so most of our code is specified as Crater City. Then we had another layer that was the SQL Azure layer that we had to communicate with. And SQL Azure and Azure in general was really, really easy. At first, we thought we were going to have to create new data services for our data. Then we figured out, well, all we need to do is load the data and change our connection string. And really, it was that simple. Let's see. What else do I have on my slides? Really, that's about it. I think I'm going to hand it over a little bit early because I probably had too much coffee and flying through my data points right now. So that's pretty much it. If you guys have any additional questions, we'll be taking questions at the end, or you can find me out in the hallway, and I can go into more details on any of those aspects.
Okay. All right. So I'm going to introduce Jeff in just a second. I want to just add on a couple more things to what Rick mentioned. We're using ASP.NET MVC 2. So this is one application that sits, it's one area amongst multiple areas inside of the site. So we actually started off, we were building these distinct experiences. So there is the map room, which you've seen, There is a visitor center map, a sort of interactive tourist map. There is the Two Moons Rove-In Theater, so it's a video theater component. And the other one escapes me at the moment. But there are four different experiences we put in as different areas. And we're using that in ASP.NET MVC2, and that works out really well for us. And the other thing to think about, what we just talked about, right, is you've got a Silverlight client that's communicating via service that's running in the cloud, that's communicating up to the Galaxy Zoo API, which is in the cloud, which is communicating back to Dallas. His API is also talking to Dallas. We have multiple SQL Azure instances, and they're all running inside of Dallas. And for us, because we have a fine layer of granularity in the way it's been put together, you can start scaling each of these individual pieces as appropriate. So today, we realized that the website was getting the brunt of the hit. We bumped those up considerably as far as the number of servers that we're using. And then we have the images stored elsewhere. So we bumped those up as well, but not quite as much, because we realized that the click-through wasn't going to be quite as heavy. But when we talk about these, if you think about the different organizations as different entities, and we're talking about something for the common good around public sector and non-commercial. But if you think about it from an enterprise perspective, this is a scenario you're going to see more and more as Azure takes off. And it's a really interesting model, and we're happy to share lessons learned about that. And no better way to do that than doing it firsthand and coding yourself. So I'm going to bring up Jeff Norris. Jeff is from NASA, and he's the supervisor for Planning Software Systems Group at NASA JPL. And he's going to talk about the Pathfinder Innovation Challenge. It's a competition we launched yesterday. Uses Azure. I'm going to turn over to Jeff, and he can tell you a little bit more about that.
Thank you, Mark. So I want to tell you a little bit about the Pathfinder Innovation Challenge, something that I'm personally really excited about, because I think it builds on some of the things that Mark was talking about earlier about citizen science and bringing people into this grand adventure of space exploration in a way that I think is new. So I'm going to tell you about it. I'm also going to invite you as developers to get involved, because you're among the people we're trying to reach out to with this challenge. So the Pathfinder Innovation Challenge recognizes that we're producing an amazing amount of data using our spacecraft at Mars and at other places. And we only have so many people on our staff to analyze this data and to understand the data. And we want to invite people to help us to do that more effectively. So what we've done is work with scientists to identify things that are interesting in Mars images. And the Spirit and Opportunity rovers have acquired more than 300,000 images so far. And that's quite a mountain of data to work with. And many of these images have things that are scientifically useful in them, but finding them is a little like finding a needle in a haystack. So if you look at those two pictures up there, for instance, the one on the left has a lot of interesting things going on in it. It has the arm of the rover in it sticking out in front of the image. It has the shadow of the vehicle, something which at times has some scientific importance. It has the horizon. There's interesting science that goes on around that. The image on the right has some other interesting things. There are layered rocks in that image. There's special kinds of rock called bedrock there. There's the rover deck itself, where you can see things like dust accumulation. And when a scientist is working with images like this, they quite often want to ask a question like, out of these 300,000 images, find me all of the ones that have this scientifically interesting thing in them. And they can either have an army of graduate students go do that and spend weeks and months accomplishing that, and that is pretty close to the state of the art right now. Or we have two ideas about how we could do that better. So one of them invites participants in the Pathfinder Innovation Challenge to write automated applications to look at images like these and find these objects of interest, which we're calling tokens. The second challenge, which is interesting, is to write a casual game that, when played, discovers those same items of interest. And one thing that I think's really exciting about that is we're not prescribing to you whether you should use the automated approach or the casual game approach for any particular token. And I think that's exciting because I don't know, even given my background, I still don't know which is the best approach for finding some of these things. And we're hoping that the developer community is going to help us discover that. So the URL is at the bottom there, and I strongly encourage you go there. What we have there right now is a place for you to sign up your email address to say, I'm interested in this and I want to be involved. There's the official contest rules there. There's also a PDF that's got a lot of the details about how you're going to participate in the challenge. Now, it's just started, so some of the infrastructure for the challenge is going to come online across the next month. But with that document, you can really get a feeling for how's this going to work, how would you get involved, and maybe if you are really eager, you can even take some of the images that we're going to be posting on that site and start playing around with it and getting used to it. We've put all of this data into into Microsoft Azure to make it possible for developers to work with this data more effectively than they have in the past. And one thing that I've heard mentioned in some talks here at the conference is that even when data is open, and NASA's data is open, of course, it's not always accessible. And accessibility is about making it such that people, like developers, can have easy access to it and easy ways to parse and understand that data. And so the way I'd like to put this is that NASA has taken the first step here in this cooperation. We put all the data into this place that we think is going to be easy for you guys to work with, and now we're kind of handing it over to you and inviting you to jump in there and help us make this data better. Now, if that wasn't enough of an incentive, because I think it's exciting enough by itself, there's a whole bunch of interesting prizes as well. If you look in the rules, you'll notice that the grand prize in a couple of these challenges is a all-expense trip for a team of 3 to the MSL launch, and that's the next rover mission that we're launching in 2011. That'll be really exciting, so to see the launch, meet the team, and things like that. And Microsoft has tossed in a bunch of other cool prizes like Zune HDs and things like that. So it not only is it for a great cause, not only is it really exciting, but also there's some pretty cool prizes as well. So I'll definitely hang around after the talk, and I'll be over at the Rover family in the big room. If anybody has questions about Mars and how we drive rovers, or the Pathfinder Innovation Challenge in particular, I'm happy to answer all of those. And did you have a few comments to wrap up at the end, or we want to go to Q&A?
Right. Wrap up quickly. So thank you very much, Jeff, for that. One thing I want to say is we had 45 minutes. There's a lot of stuff we haven't covered yet. So we haven't covered things like accessibility. NASA being a government organization, we need to make sure we covered accessibility in Silverlight. We moved the Galaxy Zoo guys over from Active Record on Rails over to Entity Framework. We didn't have time to talk about that. What I want to do is an invitation to folks here and at home who are watching us or at the office. You can reach out to me directly at mmercuri, MMERCURI, at Microsoft.com. And happy to follow up with you there. If you go to the site that's listed on the screen that Jeff mentioned a moment ago, there's also samples there for the Dallas APIs that are available today, including the 3D demo that we showed yesterday in the keynote. And I'm sure my inbox is going to get flooded, but for the first 25 people that send me an email that didn't get to be at PDC yesterday, let me know and I'll send you a pair of 3D glasses that you can check out the demo with the sample code. And with that, we'll turn it over to questions. Any questions? Bueller? Anyone? Gentleman in the back.
How long did it take from beginning to end, when you started coding, to bring this out online?
In normal time or in accelerated time? Now keep in mind that Rick really wasn't kidding, that he had been up like 50 hours, 40 hours before he came out here. It took about 3 months elapsed time. Very intense months. There's lots of stuff here. We ported someone over from a different platform. We put out SQL Azure. Dallas came up in the middle of that. We ported that over. Lots of interesting stuff, and we needed to put together a contest and things like that. So it was a very aggressive 3 months. But in 3 months, we could build all of that, which is much shorter than most business development cycles. And we hit just about every piece of the platform and the stuff we haven't talked about, like accessibility. Anybody else? Okay, well, with that, I will thank you very much. I know some people are shy about asking questions on the mic. As soon as I think it's going to cut off in just a second or 5 seconds. If there's any questions that we can answer, please do swing by, and I'm happy to do that off camera as well. Thank you.